We have a strategic insight on demystifying AI predictive maintenance in mining, fact versus fiction. Our speaker is Tomer Srulevich. Tomer is an experienced technology startup builder, angel investor, and business growth strategist. He has more than 20 years of experience in founding, managing, and advising technology companies across Industry 4.0, mining, fintech, insurtech, real tech, and intelligence sectors. Tomer currently serves as the Chief Business Officer for Razor Labs. Please join me in welcoming Tomer.
Good afternoon, everyone. I see we got 12 minutes. We were down from 15 to 12. I don't know, how did I lose 20% of my time? This is what it's about, how to reduce 20% without doing much with predictive maintenance. All right, we're back up. I hope you can hear me. Late in the day, so I hope everyone a little bit up. I want to talk about predictive maintenance and talk about three things that are mostly important about the facts and realities of predictive maintenance. Give you a glimpse into what we do. I'm Tomer Srulevich, Chief Business Officer for Razor Labs. I'm here with my colleague, Liela Nisenko, Head of Marketing. And we're here as a unique company really trying to drive innovation and artificial intelligence in the mining sector. I use this one? Okay. All right. Can you hear me if I'm standing here, or I have to be close to this one? I have to be, yes. Very important aspect. When we talk about AI, with this significant blast of artificial intelligence programs out there right now, we're all being bombarded. You know, the stock market is running like crazy, NVIDIA is climbing like crazy, ChatGPT is over the place, but they keep asking questions. Everyone are trying to understand whether AI will replace people around all over the place. Specifically in the mining sector, we know it's a very difficult environment. And I think the main answer to this question is that AI will not be replacing people. It will be those organizations that knows how to adopt AI that will be able to replace those that are lagging behind. And this is exactly where the market is shifting. And when you look at those tools around you, it will not replace all jobs, but you need to be better at what you do. And we'll talk a little bit about this one today as we move forward. The unrealized potential of predictive maintenance has been crazy. 70% of the programs that have been out there have been failing because people don't know how to leverage predictive maintenance. It's been a buzzword for too long and not really taking advantage of what the market has to offer. And it's not due to lack of trying. Companies, large and small, are investing millions in putting dozens of members, sometimes hundreds of folks, in developing models of predictive maintenance to predict failures and understand what to do with it. You just don't know what to do with it next. It gets to a point where it stops. You bring a model, and no one at site knows what to do with it. And the operator is like, all right, thank you. Great work, guys. Thank you for working on this for the last 18 months. It really doesn't bring the value that we need. I want to talk about three misconceptions and trying to cover those very quickly in the time that we have. We talk about big data versus the right data, predictive maintenance versus prescriptive maintenance, and let's talk about sensors. It's been around for a long time, but is it good enough? Is this what we need actually to create a better predictive maintenance program? I'll start with the first myth, and of course I couldn't help myself, using Midjourney in order to create some artificial pictures of the mines of the site using AI, as we all do these days. Is big data for miners that collect, is this easily leveraged for predictive maintenance? Everyone got data. You're not waiting for anything to happen. The flow of data in the last 10 years has been increasing significantly, but it's not necessarily the only thing you need to do in order to create predictive maintenance models. I think the reality is that it's not about getting the largest amount of data as it used to be in the past. Now we're talking about getting the right data in order to create what is needed for a predictive maintenance model, very specifically. I think the big data is not really the concern right now. It's understanding what do you need from within the data itself to create the right models to help predict specific failures in machinery across the organization itself. For about 30 years, organizations have been collecting siloed data on multiple different areas. Those can be in vibration data for condition monitoring that you've been all doing across different sites. in order to collect any kind of equipment, rotating devices, etc., working on oil analysis, understanding contamination, getting samples, collecting them and sending them over, telemography for overheating equipment and others, and similarly an historian, which everyone have, everything about the history that's been collected. All of those as silos has been working perfectly. The problem is that getting each and every one of them separately is like going to your doctor with an Apple Watch and asking them, diagnose my problem based on a single symptom. You wouldn't go with just heat or just a pain. You will go and you'll get your blood work and you get a temperature and maybe an X-ray, and if it's needed, you do a CT and you do more scans and everything else around it, because this is how we operate, right? Now, machines are very similar. There isn't a single reason why a motor will fail. It might be something upstream or downstream that requires and make the impact. And unless you're providing more parameters into your analysis, you're half blind. You're not looking at things in the proper way. The second aspect is more about the model that's been created. Assuming that you've been through the journey of developing predictive maintenance models, and you've excelled in this capability, and you now have a really good team that can excel it and provide it, is this good enough? Is your program working? And I think what we've heard here over the last couple of days is developing models is not the end. It's the beginning of the process. It's making them adopted and working with them to make a difference. And I think the reality is that most failure require multiple different diverse action in order to resolve it. So even if you find a problem in a very specific manner, it might be that you identify a specific deterioration using your model that a pump will fail in the next 20 days. If you don't provide a specific root cause about why is it happening, all you're doing is giving an indication, guys, it will happen in the next 20 days, 30 days, go and fix it. But then 3 months later, it will keep on happening, or 4 months later. So you've done a great work of developing great models. At the end of it, you're helping, part of the process, not really all of it. So getting prescriptive actions into your model is a critical aspect of getting those predictive models actually to make an impact on the organization. Otherwise, it's like half-baked. And it's not really providing the necessary value that the organization are looking for. Getting the action is the way to get value realization from the sites themselves. One of the examples that we had with one of our customers is when we look at the variety of reports coming out of when you look at the vibration analysis. And when you look at the vibration analysis and the report that comes together about 100 pages long and providing indication for the customers of what you need to do. And you go on the maintenance side, and if you've been there yourself or through your colleagues, you have to go to this list, find out where the problem is, go around it, identify what needs to be done, and go out and send the right guy to say there is a bearing failure. They don't really know if this is because of an overload, oil contamination, maybe there is a lubrication problem. You just send the guy and tell them good luck in what you're doing. Think about the amount of time they spend on it without really the knowledge and the skills to know what the problem is. Forget about the safety aspect of what needs to be done around it. Why not provide them with specific tools to go to fix the right problem? Shorten the time, eliminate the concern, shorten the cycles. We're getting into this endless loop of dealing with symptoms instead of fixing the problem. This is causing an ongoing operation. You're feeling you've succeeded, but the teams are just doing their work, and they're a very limited amount of time on site, whether it is an 8 to 6 schedule or 9-5 or whatever the site schedule is. I think putting the teams in hazardous location or making sure that you put the wrong location is really terrible. When you go out and you don't know what needs to be done, it goes all the way from supply chain and parts need to be deployed into site, into individual going into the right place. So being extremely accurate in what's the prescribed action needs to be done is extremely important to go after it. Which leads us to probably the last myth that I would like to cover around sensor deployment. I've heard throughout this conference and other that, we already deployed. Some organization deployed 1,000 sensors for a certain company in one of the caves, one of the largest caves in the world. And the result was amazing because they were so excited about the deployment of the sensor, only to find out 9 months into the process that 85% of them are not even connected. But they've done the process, and they procure it, and they deployed it, and it took 2 years just to deploy the process itself, but it's not working. So getting sensor is not enough, even if they're connected. Just getting the data itself will not yield predictive maintenance. Online ability doesn't equate predictive maintenance. When you have sensors, doesn't mean that you got everything lined up and it's all working. You still need to do the work. And if you've been to the process, collecting the data, processing the data, and analyzing it requires significant resources. It's only part of the way to get sensors involved in order to build the right information. Built-in analytics in certain sensor company, and all of them are pretty good, provide you just a narrow view of what they can actually provide. So combining all of those skill sets together, similar to the human body, right, with blood work and X-ray and CT, and everything together, gives you the more indication about what needs to be done. So think about it as you move forward and combining different sources from different companies in such a way that allows you to leverage those. I think just sensor themselves is not suitable. You need to get something that is more comprehensive for this regard. When you combine multiple different levels of sensors, you can look at all of them together and say, all right, now I can rule off a specific problem in overload. Because I look at my vibration and I look at my current and temperature in a specific bearing, and I will know this is not really overload. So the guy doesn't need to go in this direction. And you go around the belting balance and you can see the vibration and you can look at the camera and you can see, well, it's not really this problem. So I can focus specifically on the problem at hand by analyzing vibration, oil, and pressure, understanding specifically there is a problem with lubrication failure, and then provide some specific root cause analysis and prescriptive action. What do you need to do? What is the impact of this one? And why is it important to combine those sources to get some prescriptive action? Because only the combination will give you the right root cause, where a single source is extremely hard to do. In one of the examples that we're looking at, when you have a vision of a conveyor belt, and many of you mentioned there is capabilities and analytics around, you can see at one point that there is a drift and there is a capability to identify problems in the specific load of the conveyor itself. A combination of this with vibration analysis will let you know whether it's a pulley wear, whether it's an impact itself. What is the problem? Is it because something is shifting, the ore is coming together, the vibration is causing a concern? Or maybe if you look at the ore on the actual conveyor, you can find out based on the size of the ore if there is a problem ahead. Maybe there is a tooth missing on the crusher. Maybe a screen has a hole in it, and ore is falling in the right and the wrong sizes. So combining different aspects in providing analysis and root cause is critical for this purpose. An all-in-one solution allows you to look at all of those together, the analysis of different data sources, providing the support and the capabilities. That's what RazorLab and DataMine provide to the customer itself. And like us, there are many in the company, I think in the industry, that are looking to provide capabilities to do fusion of different data sources. And even within organization that you're working in today, try and get the data sources in order to look for the root cause itself and not just to build models. I want to leave you with a few takeaways before I'll open it for questions. Condition monitoring is critical. I think we need to continue doing the condition monitoring and collect it. It's an effective process moving forward. The right data is where we need to be focusing on. It's not about big data. It's not collecting everything that we talked about. We spoke with folks here that are throwing terabytes of data on a daily basis from mine sites. Some are more advanced than others. That's fantastic. Focus on the right data. Not everything is required, but the ones that are required are extremely essential in order to move things forward. Failure prediction and prescriptive actions are critical to organization. If you want your teams to be more accurate in what they do, avoid spending time, figure out what needs to be done, be prescribed, be actionable, build a model that has a means to an end, work with a team on site that knows what they're looking for so they can actually recommend the action, take an action, go to the bearing, check what's going on, understand whether there's a lubrication problem, go and lubricate it and come back and say, yeah, thumbs up, it's good. It's not just letting the model to learn. It's the ability to actually work together and collaborate and have very prescribed action. We didn't talk about the human element in this one. At the end, you need trust. The team on site could care less about the latest and greatest technology. You need to build trust with the maintenance team on the ground. They need to understand what you're doing here is helping them. So it's the process of closing the loop, making sure that you're building trust with the teams. They understand technology is here to help them eliminate wasteful time and really prevent unnecessary downtime. When we talk about root cause analysis, this is one of the critical items that is required in order to understand more about what happened. And of course, sensor fusion, the ability to combine sources of data from multiple locations, ideally in real time, in online capability. And of course, keep on analyzing the data. We've been in a site where we saw flotation cells, and looking at the bubble size of the flotation cells, there were 8 screens, and no one is looking at them. They invested a lot of time in putting cameras, looking at them all the time, seeing what's wrong, but no one was looking at it. So connecting technology to enable online monitoring of this equipment and fitting it into a platform is one of the key aspects in identifying root cause and problems. And of course, take action. Folks, I've been Tomer Srulevich. It's been a pleasure. We're Razor Labs, publicly traded companies, and we look forward to hearing any questions you may have. Thank you. One question about pre-installed sensors. Yeah, absolutely. You can use any kind of sensor. We don't have any preference, but when you look at pre-defined sensors on site, what happens if you have already? Yeah, of course, you can use internal sensors, you can use off-the-shelf sensor, you can use something that you already have. The idea is to combine the knowledge of all of those together and make it happen. Any other question? Good. Thank you very much, everyone. I appreciate it.